Hello and greetings to everyone. We are from Technopreneurs Group. In this video, we are going to teach you about line and block coding. For this video, we are going to focus on 5 types of block coding, which are differential Manchester, multi-level, multi-transition, BXZS, and HDB3.
Hello there, my name is Ahmad Akram Zulfikkar, and right now I'm going to explain to share with you about differential Manchester. In differential Manchester encoding, it is about the inversion at the middle of the bit interval is used for synchronizations, but the presence of an additional transitions at the beginning of the interval is used to identify the bit. And from here we can see a transitions means binary 0 and no transitions means binary 1. So the differential Manchester encoding require 2 signal changes to represent binary 0, but only 1 to represent binary 1. Okay, from the beginning, here it starts with a 0, and when the transition change, it will change into 1. And we can see after this binary 1, and the transitions still remain the same shapes, it represent as binary 0. And when you can see the changes of transitions, the binary change into 1. We can see as the following: the transitions is changed, and it is 1. So that's meant to be the differential Manchester.
Let's look to this example for our good understanding. We can look here. There are 8 bits: 0, 1, 1, 0, 0, 1, 0, 1. From this code, we can see that there are 4 zeros and 4 1. Means that in this kind of codes, there are 4 transitions that happens along the way.
My name is Haziq, and I'm going to explain on multi-level transition, as known as MLT3. This signal is a signaling method used in a telecommunication system for transmission purpose. MLT3 has 3 values. As you can see, this is the positive line, neutral, and negative. And here we have an example of a set of bits, and we start from neutral. The next bit is 1, so there is a change. So we will go upwards to the positive level here, and then the next bit is 0. The next bit is 0. When there is 0, there will be no change in the graph, and after that we will meet 1 now. So there will be a change in the graph, so we will go downwards. Alright, and then we have 0 and zeros, absolutely no change. Okay, and then we meet 1. At this point, you have to figure out if the graph will go upwards or downwards. We have to decide on the previous one. We cannot go to the level that we came from. We came from the positive level to the neutral, and then to the negative. So the next one for this bit, it will go to the downside, negative. As you can see, we have a change. This bit is 1, and we will go upwards, and then there is also a change here. We will go upwards, and there is 0, 0, absolutely no change, and then we have 1. This one will go downwards as we came from the neutral level to the positive level. Alright, that's all. Thank you.
To recap on the multi-level transition, we can say that multi-level transition is a signaling method used for transmission purposes. Usually, it uses 3 voltage levels. Basically, it cycles sequentially through the voltage levels -1, 0, +1, and 0 again. If we look to the graph, if the state is changed, it will be represented by number 1 bit to represent there is a transition occur. If the graph stays in the same state, it will use number 0 bit to represent there is no transition occur.
Hello, my name is Syahmi, and I'm going to talk about multi-level to binary 1 quaternary, also known as 2B1Q, which is used in ISDN that represents a pair of binary digits that represents 4 discrete amplitudes and polarity value. In 2B1Q, two binary bits are encoded into 1 quaternary signal, doubling the effectiveness of transmission. Okay, this is the 2 binary digits that are encoded together. The example, this is the table. Okay, to minimize error propagation, repairs are assigned to a voltage level. So this is the voltage level, the line, the pink one. According to the table, the 2B1Q, they depends on the previous level so that they can move on to the next. For example, the first 2 binary bits, we assume the previous level is positive, so that's the previous level is positive, so they stay on +1. According to the table, +1. And the next one is 1, and the table, the previous level is positive, so it will go to -3, and it will stay on -3 because the next one, 0, 1, is also -3 by looking at the previous level, which is negative. We continue to the next 2 bits, 1 and 0. The previous level is negative, so 1, 0, negative, it will go to +1. And the last 2 bits, 0, 1, the previous one is positive, so it will go to +3. Okay, that's it. Thank you.
Let's do some recap on the multi-level. It is a 4-level pulse amplitude modulation. Usually, it maps 2 bits into 1 quaternary symbol. It is known as 2B1Q scheme. To minimize error propagation, bit pairs, or is known as D-bits, are assigned to voltage levels. As we can look at the table, we can see the D-bit and the signal level. There are pairs of D-bits. There are 1, 0, 1, 1, 0, 1, and 0, 0. And each of them are assigned to their respectively signal level, which are positive 450, positive 150, negative 450, and negative 450.
Okay guys, today I'm going to explain about bipolar 8-bit zero substitution. Bipolar 8-bit zero substitution is based on bipolar AMI, that is alternate mark inversion. Bipolar alternate mark inversion is about sending 8 zero sequences of signal. So when the sender send the signal, the receiver will receive like this: 2, 3, 4, 5, 6, 7, 8. So the receiver will only receive 7, not by 8. This is because as the time passes, the clock tends to drift away and it is not synchronized. So bipolar 8-bit zero substitution is the way to scramble the problem. So it uses this set of code. This. So first we start with positive voltage, same as BAMI, bipolar AMI. Then negative voltage. Then because this is negative, so we use this negative set of code. So after that is 30, and then it's negative signal, followed by this violation of the signal, and valid bipolar signal, and then 0 back, then violation again, and then valid bipolar signal. So when the sender sends the signal, the receiver will read as 0. This violation is used to break the rule of bipolar AMI. So the receiver will reset their clocks, and after that it will follow back as this one, as the former scheme of code. Okay, that's all about bipolar 8-bit zero substitution. Okay, thank you.
Next is BXZS. BXZS is the short form of bipolar 8 zero substitution. It is a type of scrambling method. It inserts two successive ones of the same voltage into a signal whenever 8 consecutive zeros are transmitted. It is referred as bipolar violation. When successive ones are transmitted, one has a positive voltage and the other has a negative voltage. Hello, my name is Ahmad Farid, and right now I will explain to you about the HDB tree with high density bipolar tree, which is one of the method for scrambling, that is to provide the synchronization of the data for the receiver. Okay, first we have to refer to the table, which we can see the last pulse, the odd, and the even. Okay, the last pulse, we can see that there are two types, which are negative and positive. Then if the number of the last pulse, if odd, there are two types of code here. And also for the even, there are also the particular number of particular type of code here. So by looking at the graph, okay, the first part is 1 and 1, which we can look to both of them are at different level, one at negative and one at positive, which we can see is it's as synchronization. Then for the second one, we can look it is at the negative level. So for those zeros here, we can look to the table, which is okay, the negative, then we can use the odd part here, means that 0, 0, 0 and negative. So at this part we can see that violation is happening. Then when we see this this part is occurring at negative level, so we can use the even part, means that 0, 0, positive, 0, 0 and positive, which that one of the positive level is valid bipolar signal and the other one is violation, which means the disturbance between the valid bipolar signal and the other one which is occurring at the negative level. Then we can see that the other one is occurring at the positive level, which we can see the synchronization. Then this part we can see that the number one is at positive level, so we can use the code down here, means that negative, 0, 0 and negative, which means that the first negative level is being valid bipolar signal and the last part is the bipolar violations, which means the disturbance between this kind of basic bipolar signal and the last number one here. And then, do you want to know why this kind of graph is like this? Because this is the way it is. Thank you. The last one is HDB3. It is a short form of high density bipolar tree. The HDB3 code is a bipolar signaling technique. It is being used by inserting violation codes whenever there is a run of 4 or more zeros in a line code.